This first lesson is on types of functions, or as I will refer to them from now on as base functions. We are going to be going through 5 base functions today. Most of them will be familiar to you. A couple of them you will probably need to do a little bit more memorizing. The first function that we're going to start with should be the most familiar since you've studied it in depth in grade 9 and grade 10. So the first function that we're going to be talking about today is the linear function. Now, when I refer to a linear function and its base function, I'm always going to be referring to this function right here. F of x is equal to x. Now, we know that the equation of a line is y equals mx plus b. And we know that this m is the slope and this b is the y-intercept. But when I'm referring to a base function, all I'm referring to is just the line x. So that's the line that goes through 0, 0, and up like this. Now for all of these base functions, you need to memorize the base function itself, what kind of function it is. So in this case, f of x equals x is a linear function. And you will need to have a mental picture of what this graph looks like, along with a few key points for each one. Now the key points for this base function linear, or f of x equals x, is 1, 1, 2, 2, 3, 3, 4, 4, etc. I'm going to suggest that somewhere you keep a copy of this note or you keep a copy of these base functions handy so that you can refer back to these key points as we move through the lessons in this chapter. The next function that we're going to be talking about is the quadratic. Its base function is just x squared. So again, you're going to notice that that's just our basic quadratic equation or our basic parabola without any transformations. So no shifts, no stretches, none of that we talked about in our previous chapter. You will need to memorize the graph that goes along with this. So here we have our base function x squared. Now, again, we do need to memorize a few of these key points. So for our base function x squared, we do know that this graph is going to start at 0, 0. Now, because of the step pattern, we know that our next is over 1, up 1 from that origin. So 1, 1, and it will be the same to the left, so a negative 1, 1. Now, from that second point, we're going to go over 1 again and up 3. So our next point is 2, and then 4. And so same thing on the left side, a negative 2, and then a 4. So memorize quadratic. Our base function is x squared along with these key points. A couple of things I did want to mention just for in the future. You know that even though our base function is x squared, we can write our quadratic a couple of different ways. So because we have had a few chapters on this already, we know that we could write it in standard form, ax squared plus bx plus c equals 0, or we could be writing it in vertex form, so y equals ax minus h squared plus k. We could also be writing it in factored form, x minus r and x minus s. Now I'm going to go ahead and I'm just going to change this so that it doesn't equal 0, just so that it equals y and doesn't confuse anybody. Our third base function is going to be the rational function. So its base function is written as f of x equals 1 over x. Now it's important to know a couple of things about rational functions. So rational functions can be written as p of x over q of x, where p of x and q of x are polynomials. Now there's a lot going on in this function, so I'm going to draw you a quick diagram of what this looks like, and then I'm going to be explaining a couple of these key features. So our graph of 1 over x is a very strange graph. We did talk about it very briefly in our last section homework. I did have a couple of emails about it or questions about these graphs. So this is the graph of 1 over x. There are only two key points that we can really memorize. So the first key point is 1, 1, and the second key point is negative 1, negative 1. Now you're going to notice that this graph does kind of do some strange things. So it gets very close to the x-axis over here, but it will never touch it. Same thing with the y-axis over here. Now the left-hand side will get very close to the x-axis here and very close to the y-axis here. Now that's because of these imaginary lines that we're going to be calling asymptotes. So we know when we look at this equation that we can never plug in an x of 0. We can never have 1 divided by 0. That is mathematically impossible. We know that this graph, when we graph it, can never ever cross an x-axis. So what that means is that we are going to be getting very close, so close that to the human eye it would look like it touches, but it really will never touch. So I'm going to, other than having you memorize these two key points and what the graph looks like, I'm just going to explain it with a table of values a little bit. So if I have x and f of x, which we know just means y, if I plug in 1 over 1 is 1, so this is where we get that key point 1, 1. If I plug in 2, I get 1 over 2 as my function. So I can see that as I go to 2 on the x, my graph is getting closer to my x-axis. If I plug in 3, I get 1/3. Now I'm going to skip 4, 5, etc. and I'm just going to plug in 100. I'm going to get 1 over 100. We know that that is a really small decimal. I will never ever get anything hitting 0 or below 0, no matter however big I plug in an x value. The exact same thing is going to go. I'm going to just draw another one here, x and f of x, if I start plugging in negative numbers. So if I have an x of negative 1, 1 divided by negative 1, I'm going to get negative 1, which is that second key point that I told you about. If I plug in negative 2, I'm going to get negative 1 over 2. Negative 3, I get negative 1 over 3, and negative 100, I get negative 1 over 100. So again, this is why my lines get very close but will not touch. The fourth base function that I'm going to be talking about is the radical function. We've dealt with radicals a lot this semester already. You know how to simplify them. We have worked with them. We have never really graphed them. So the base function for a radical is just the square root of x, no other numbers involved, no negative signs involved, just plain old square root of x. Our base function will look like this when we graph it. Now again, at any point, if you forget what this base function will look like or what these key points are, you can do a table of values for yourself. So the first key point that we're going to be thinking about is 0, 0. So if I plug in a 0 for x, the square root of 0 is 0. Now, the next key points are all going to be points involving perfect squares. And you're going to see, I'm not going to make you memorize a key point that's a decimal. I want all of your key points to be nice round numbers. So the next key point that we're going to be talking about is 1, 1. If I plug in an x of 1, the square root of 1 is 1. The next point after that is going to be 4, 2. So if I plug in an x of 4, the square root of 4, or my y value, will be 2. And then I'm sure that by now you've guessed it, our final key point is going to be 9, 3. So if I plug in an x value of 9 to my function, the square root of 9 gives me f of x, or y, of 3. You may also notice that there are no negative x's or no graph in the negative x quadrants. That is because we know that we cannot take the square root of a negative number. So my entire graph is going to be in quadrant 1. Our fifth and final base function is the absolute value function. So the base function for this function is just the absolute value of x. Now, if you don't know what an absolute value is, anything inside of these straight lines that you're going to see right here will be turned positive. So the absolute value is always a positive answer. Now, again, I'm going to give you your graph and I'm going to talk about why we're getting the values that we are getting. So the graph of an absolute value looks like this. Now, if I think about my table of values and how we can get some key points, I'm going to start with my -2. Now, if I plug in a -2, I see right here that the absolute value will just make that a +2 for my answer. So 1 point is going to be at -2, 2. Now, if I plug in a -1, the exact same thing happens. I'm going to get -1, 1. 0. 0 is already positive enough, so I have a 0, 0. 1 is already positive, so I'm going to get a 1, 1. And 2 is already positive, so I'm going to get a 2, 2. So basically, what this represents is our y equals x function right here, and the exact same function mirrored over here because of the absolute values. This ends our summary of our 5 base functions. As I have said multiple times, please make sure that you're keeping these 5 base functions and their corresponding graphs in a safe place. You will be referring to them frequently for the rest of this chapter, even for the majority of this course. Fairly soon, I'm sure you will have them memorized and you won't need it as much, but it's always good to have it in a safe place just in case.